Welcome to How to Assign Oxidation Numbers. So oxidation numbers are just a bookkeeping system for electrons. And really there's just a series of rules for these oxidation numbers. The first is for an atom in its elemental form. The sign is 0. So an atom in its elemental form would be just sodium metal, which is in its elemental form. It would have an oxidation number of 0. We could also think of something like hydrogen gas, which is in its elemental form, which is also going to have an oxidation number of 0. For monoatomic ions, the oxidation number is just equal to the ionic charge. So in this case, if we were to think about sodium ion, which is Na+, it has an oxidation number of +1. Whenever we talk about the nonmetals, there's a bunch of other rules. Usually these are going to be negative oxidation numbers. Oxygen is pretty much always -2 for ionic and molecular compounds. The only exception is when you talk about peroxides, which we don't encounter that often. Hydrogen is going to be +1 when bonded to a nonmetal, and it's just -1 if it's bonded to a metal. Fluorine is always -1. Other halogens are pretty much -1 as well in any binary compound, which just means that it's composed of 2 or more atoms. The biggest and most important rule is Rule 4, which says that the sum of all the oxidation numbers for part A of all atoms is 0 for neutral compounds, meaning that if you have some kind of compound like sodium chloride, this is a neutral compound. The sum of all the oxidation numbers has to be equal to 0, which we know that sodium would be +1 because it's a sodium ion, chloride is -1, and so when we add those together, they're 0. Makes sense. In a polyatomic ion, it equals the charge of that ion. So when we look at something like sulfate, SO4 2-, the total oxidation numbers for all the sulfur, all the oxygen, has to be equal to -2. Those are probably the 2 most important rules that you'll need in order to solve for the oxidation numbers. That concludes how to for oxidation numbers.